Hey guys, welcome to ANS Solver. Today we'll be doing the concept of combining trigonometric identities with integration, which is a subtopic in the chapter of integration. Okay, so basically in the previous video we learned, the integration of sin x and cos x. But what if, I ask you the integration of sine square x dx? Or what if I ask you the integration of cos square x dx? Okay, so you need to know that the integration for these are not direct at all. Okay, you need to recall your trigonometry for this. Actually, in the full chapter of integration, it's really important for you to know your trigonometry identities very well. Okay, so you know that cos 2x is equal to 1 minus 2 sine square x, and you know that cos 2x is equal to 1, sorry, not 1, cos 2x is equal to 2 cos square x minus 1. So now basically what you can do is to integrate sine square x, you can use the identity that states cos 2x is equal to 1 minus 2 sine square x. Here what you can do is you can make sine square x the subject of the formula. So I get 2 sine square x, which is equal to 1 minus cos 2x first. Then I can write my sine square x as 1 over 2 minus cos 2x over 2. Correct? When I take 2 down. Now what I can simply do is, in the place of sine square x here, I can simply substitute 1 over 2 minus cos 2x over 2 dx. Okay, so now I have the integration of 1 over 2, which is simply 1 over 2x, minus, what is the integration of cos? It's sine, so I write sine 2x, correct, and divided by, I know I have a pre-existing 2 here, so I write that 2, but this will be multiplied by the differentiation of 2x, or the coefficient of x, which is 2. And I'll add a c as there are no limits. So I can write this simply as half x minus sine 2x divided by 4 plus c. Correct? This is how I can simply write it. Now I have in the same way the integration of cos square x. So I know that cos 2x is equal to 2 cos square x minus 1. So I can write this simply as, I can make 2 cos square x the subject of the formula, so I can write this as cos 2x plus 1, which is equal to 2 cos square x. So I get my cos square x basically as 1 over 2 plus cos 2x over 2. Agreed? Now what I can do is I can write this as the integration of, in the place of cos square x, I can simply put 1 over 2 plus cos 2x over 2 dx. Now what is the integration of 1 over 2? It's simply 1 over 2x plus, what is the integration of cos? It's simply sine. So I write sine 2x divided by, there's the pre-existing 2, which will be multiplied by the differentiation of 2x, or the coefficient of x, which is 2. Correct? This is what I'll get. Plus I'll get a c, obviously. Okay, so now I can write this as half x plus sine 2x divided by 4 plus c. Okay, so basically the main motive of this concept was that you need to know that sine square x and cos square x cannot be just, integrated directly. You need to use the cos double angle formula, which is really important for both of these to get your final answer. Correct? Now, what we can do is, there are other important conversions which you need to know. Okay, let's say if I ask you, what is the integration of sine square 3x dx? Okay, so this makes it, a little more complicated, correct? But now for this, we will learn this in the chapter of trigonometry. You need to know basically those conversions. You know that cos 2x is equal to 1 minus, 1 minus 2 sine square x, correct? So if you notice here, when I had an x here, okay, I had a 2x here, correct? Basically the coefficient of x here is 1. So when I do 1 into 2, I get the coefficient of x here, which is 2. In the same way, if I write sine square 3x, which I have in this case, so I'll have the 2, correct? I'll have all of this in the same way, but this will be equal to cos, okay, this is important, this will be cos 6x. Why? Because when this was 1, this was the double. So now when this is 3, this becomes 3 into 2, which is 6. This is the important thing which you need to know. So basically, now I can make sine square 3x the subject of the formula. So I can write this as sine square 3x, which is equal to 1 minus cos 6x. So now I can write this as sine square 3x, which is equal to 1 over 2 minus cos 6x over 2. Now I can simply substitute and write this as the integration of 1 over 2 minus cos 6x divided by 2 dx. Okay, now I have the integration of 1 over 2, which is 1 over 2x, minus I have the integration of cos. What is the integration of cos? It's sine. So I write sine 6x divided by, there's a pre-existing 2, so I write the 2, multiplied by the differentiation of 6x, or the coefficient of x, which is 6, plus c. So I can write this as half x minus sine 6x over 12 plus c. So the important thing was to understand this conversion, that when this is x, this is 2x. So when this becomes 3x, this becomes 6x. So let's say if I give you something like the integration of cos square 4x dx. How do I do something like this? So basically, you know that cos 2x is equal to 2 cos square x minus 1. That means here I need a cos square 4x. So when I make this cos square 4x here, and I write this as 2 cos square 4x minus 1, this will be equal to cos of 8x. Correct? Why 8x? Because when this was 1 here, because if you see x here, it has a coefficient of 1 because that's square. Okay. So x basically has a coefficient of 1. So when this was 1 here, this was 2x. So when this becomes 4x, this becomes 8x. Correct? We did this in the chapter of trigonometry also. So now I can make cos square 4x the subject of the formula. So I can write this as cos 8x plus 1 divided by 2, correct, which is equal to cos square 4x. Agreed? So now what I can do is I can simply write this as the integration of cos 8x divided by 2 plus 1 over 2 dx. Basic substitution. So now I have the integration of cos, which is sine. So I write this as sine 8x divided by, I have the pre-existing 2 multiplied by the coefficient of 8x. Sorry, the coefficient of x, which is 8, plus the integration of half, which is half x, plus c. So I can simply write this as sine 8x divided by 16 plus x over 2 plus c. Correct? So this is basically the final answer. Okay, so this is basically what you need to know. Okay, the conversions, and this is how they can even ask you. So for your knowledge, you even need to know that that sine 2x is cos x, 2 cos x sine x, correct? So this can also be written as, if I ask you something like sine 4x, this will be equal to 2 cos 2x and sine 2x, correct? Because here the coefficient of x was 1 and this was 2x. So basically when this becomes 4x, this doubles. So even the x doubles to 2x. Correct? So this is basically the important conversions which you need to know. Okay. So yeah. So thank you for watching this video. We'll do some more advanced, identities in the next video. Okay. That will be, something from the MF19. Okay. Some unique questions which they normally ask. Correct? And about the past papers also, we've made a separate video for the past paper practice, because first you need to, have a good grasp from the concept, and then we'll move on to the past papers. So yeah, see you in the next video. Thank you very much for watching.